we know that how the operators j square, jz and ladder operators j plus minus act on the ket jm. Now let's do how the operators jx and jy they act on the ket jm. We know that ladder operator j plus is given by jx plus iota jy and j minus is given by jx minus iota jy. Once we add the two, we will be getting j plus j minus is equal to 2jx, or from here we get jx is equal to 1 by 2 into j plus j minus. And once we subtract the two, we will be getting j plus minus j minus will be equal to jx will get cancelled, and we will have iota jy plus iota jy. That is, jy will be equal to 1 over 2 iota j plus minus j minus. To see that how this jx and jy act on ket jm, we write down jx acting on ket jm. We will be getting 1 by 2 j plus j minus acting on the state jm. We have already done this, that it can be written as 1 by 2 j plus acting on ket jm plus j minus acting on state jm. This we did in our last talk, that when j plus acts on the ket jm, we get the value as h bar into under root j minus m into j plus m plus 1, and the state becomes j and m changes, it rises by 1, m plus 1. Similarly, when j minus acts on the ket jm, we get h bar into j plus m into j minus m plus 1, and the state decreases, m state, it decreases by 1. So it becomes j and m minus 1. Substituting these values, we will be getting, when jx acts on jm, we get 1 by 2 into h bar under root j minus m j plus m plus 1 state j m plus 1 plus h bar under root j plus m into j minus m plus 1, and the state j m minus 1. Now let's see how jy acts on state jm. This will be equal to 1 over 2 iota into operator j plus minus operator j minus acting on ket jm. So we get 1 over 2 iota, then j plus acting on ket jm minus jm acting on state jm. Let's substitute their values. We will be getting 1 over 2 iota into h bar under root j minus m into j plus m plus 1, and the state changes, m state changes, we get m plus 1 minus h bar under root j plus m into j minus m plus 1, and the state becomes j m minus 1 state. So now we have got how the operator jx and jy they act on the kets jm. By knowing all the operators and how they act on the state jm, now we are able to write down the matrices for different angular momentum operators. That means how we can write down, now we are able to write down the matrix elements of jz, j square, j plus minus jx as well as jy. Let's write it down. We know that if A is an operator and it acts on the ket Jm, then its matrix elements are written as J dash M dash, operator A, and the state Jm. So in this way, first of all, let's write down matrix elements of J square. This will be J dash M dash, bracket vector J dash M dash, J square, ket vector Jm. When J square acts on ket Jm, we know that we get the value as J dash M dash, we get the value h bar square under root, h bar square j into j plus 1, and the state is Jm. As this is a number, I can bring it out. I can write it down, j into j plus 1 h bar square, inner product of j dash M dash and Jm. This is a delta function. So I get this to be equal to j into j plus 1 h bar square delta jj dash delta mm dash. That is, the matrix elements will exist when j will be equal to j dash and m will be equal to m dash. That is when row and column are equal. So that means number of row and column that is equal. That means the diagonal elements. So this is a diagonal matrix. Similarly, the matrix element of Jz will be J dash M dash Jz Jm ket. When Jz acts on Jm, we get the value mh bar. So this will be equal to bracket vector J dash M dash mh bar ket Jm. Mh bar, inner product of bracket vector J dash M dash and ket Jm. It is a delta function, mh bar, delta jj dash and delta mm dash. Only the diagonal elements of this matrix will exist. Now let's write down the matrix elements for J plus operator. Matrix element of J plus operator will be written as J dash M dash, bracket vector, then J plus J dash M dash. We have done it. Then when J plus acts on the ket J dash M dash, we get value J dash M dash, and it is J dash M dash and Jm here, J dash M dash. Then the value is under root h bar with the under root j minus m into j plus m plus 1, and the state m changes by 1. That is, now we have got j and instead of m the state will be m plus 1. We bring it out. It is h bar under root j minus m into j plus m plus 1, inner product of bracket vector j dash m dash and then ket j m plus 1. This is inner product of, let's concentrate on it first, inner product of ket j dash m dash and then j m plus 1. This is another delta function. Delta function is 1 when the two are equal, the states are equal. That is when j dash will be equal to j and this will be equal to this. Otherwise, delta function will be 0. So that means this is delta function. I write down j dash j delta m dash and m plus 1. That means now this delta function will be 1 when j dash is equal to j, and this delta function of m dash m plus 1 will be 1 only when m dash is equal to m plus 1. This is a point to be noted here, that this will be 1, this delta function will be 1 when m dash is equal to m plus 1. Otherwise, this will be 0. So that means this is not a diagonal matrix. The matrix elements are given by h bar under root j minus m into j plus m plus 1 into delta of jj dash and delta m dash m plus 1. So to overcome the confusion, let's write it down, delta j dash j and then delta m dash m plus 1.